Hey everyone, welcome to 3.3 Unit Vectors. This is a quick reminder on page 283. There's a big blue box that has all sorts of stuff dealing with vectors and scalars and vector addition and subtraction and multiplying and all that kind of stuff. And basically what you kind of see is that the arithmetic properties hold for vectors. So you can add vectors and it's not gonna blow up. It's gonna be okay. You can add, you can do, let's see, like the associative property, distributive property, all that stuff still holds with vectors. It's not just working for just single numbers. All right, so right now we are going to look at unit vectors. A unit vector, it's like a vocabulary term. A unit vector is a vector that has a direction and has a magnitude of 1. So you say, why? What's the point? Why do we need to know a unit vector? Why do we need to know that it has a direction anywhere and a magnitude of 1? How does that really help us, and why do we have to do all this extra work for it? It's not, first of all, it's not a lot of extra work. Second of all, if we look at the Cartesian plane, regular grid, and also with physics, we have a lot of things that deal with physics with vectors. We have x's and we have y's, right? And so what we want to do is we can get anywhere on this grid over here or over here by going left or right first and then up or down. Okay, so if I can move 4 to the left and 3 up, then I can just take my unit vector of 1 and go 4 to the left, multiply by -4, and if I want to go 3 up, multiply my unit vector vertically by going up 3, and then we can do this, and it kind of messes with you just a little bit. Alright, so if we have unit vectors, then we can say any direction x and any number y, and we can get anywhere on the grid. Okay, so let's try this out. What we want to do first is let's do this example of finding the unit vector in the direction of v. So that means I have a specific direction, -2, 5. So what I'm going to do is use this right here. The unit vector is the regular vector divided by its magnitude, or 1 over the magnitude multiplied by the vector. So we have -2, 5. So what I'm going to do is I'm going to write it as -2, 5 in my pointy brackets, and I'll divide that by the magnitude. The magnitude is going to be the square root of -2 squared plus 5 squared. -2 squared is 4, 5 squared is 25, so the square root of 4 plus 25 is going to be the square root of 29. So I can't reduce that or anything like that. It's as reduced as it can be. So my unit vector is going to be -2 over the square root of 29, comma, 5 over the square root of 29. Keep my pointy parentheses, and that is it. So that would be the unit vector in this direction. Okay, so that means that still these numbers on top are the same, so it's just each one divided by the magnitude. Not too bad, actually, because it's already in the form. It's not like you have to do the distance formula or anything like that, because you already know what the distance is. All right, so again, why do we really need to know this? We're going to deal with the standard unit vectors. The standard unit vectors are I and J. Those are the letters they use. I'm not really sure why, but I is in the X or horizontal direction. All right, it's in the X or horizontal. We would call it X on the Cartesian plane on the regular graph, but they also call it the horizontal, especially when you get into physics. We're talking about horizontal versus vertical. All right, so J is going to be the Y or vertical direction. Okay, and if we know any vector, let's say like this one right here, I can get to from this point to this point, not necessarily diagonally, but I can get there by going up first, which would be some number, let's call it, I don't know, A, in the J direction. All right, J is the vertical. And then we could also go this way to here, let's call it B, in the I direction. All right, so I can multiply my I, which is a scalar, which let's say it's just like right here. This one would be I. But if I multiply it by b, I can get all the way out here. And then j would be more like this one right here. So that would just be my normal j, my scalar, my unit vector, and if I multiply by a, I can get up here. So that's why we're going to use unit vectors, because then we can go from here to here using i's and j's. We can get anywhere that we want on a regular coordinate grid. All right, so we're going to write a vector as a component form of horizontal and vertical vectors. It's really not as bad. It may seem confusing because it's the first time you do it, but it's really not bad. So let's use our u as 6, 7. That means I'm going 6 in this direction, right? If my original is 1 for I, what do I have to multiply I by to get out here? That's right, 6. So this is going to be a 6i, because it's 6 in the I direction, and I is the one that's horizontal. And then I have to go up to here. Now this one would be my j, my unit vector in j. It's going up 1. If I want to have it to go up 7, the whole thing, what do I have to multiply the j by? My scalar? It would be 7. 7j. So if I wanted to rewrite this vector in terms of my unit vector components, 6 or I and j, I could rewrite u as u equals 6i plus 7j. And that would be it. All right, what I would like you to do is I want you to write out the component form, right? The component form of the vector. Let's say v, let's use v, equals -9, 3. All right, and that is it. Hopefully it's not a big deal. Hopefully you know this is in the x, which is the I, this is in the y, which is the j vector for unit vectors. Good luck.